you can use that for to find the gradient of a line, especially a tangent to the curve. I won't spoil the surprise. So it'll look like this. Let's just take a look. So if you found, this point A, if you found if you found the gradient of the curve at A, that would be the same as the gradient of the straight line tangent to the curve at A. Okay. So any idea how you go about this one?
So would you make it 3x squared minus 6x plus 2 minus 0?
Yeah.
And then could you simplify? Which gets rid of the 0.
Yep.
And then do you do something with the coordinate of this part?
Yeah. Any idea what you'd do?
No.
You'd sub it in.
So just 3 for x?
Yes, correct. Because there's no y, so just 3 for x.
Which is 11.
So that's 11.
And then do you do the same with 5?
No, that's y. This is x.
Oh yeah, we're doing,
So the gradient is 11. We want the equation of the tangent. The equation of... So this is the tangent, this straight line.
Yeah.
All straight lines can be written in the form y equals mx plus c. We found m. Now we just need c.
Okay. So do we need m2?
There's only one m.
Okay.
We need c. So we now have it as y equals 11x plus c.
Yeah.
We need to figure out what number c is. Any idea how we do that?
Instead of y, would you put x cubed minus 3x squared plus 2x minus 1?
You could. That'd be an incredibly long way of doing it. What else is what else is y?
3x squared minus 6x plus 2.
That's dy dx. Y is also 5.
Yeah. And then could you... So it'd be 5 equals 11x plus c.
Well, what is x when y is 5?
5x.
No. When y is 5. No. When y is 5, what is x? What x value gives you a y of 5? When x is 3. 3, 5.
So do you want C on one side?
Yep.
So you could just do minus 33 on both sides.
Yep.
Which gives you minus 28 as C.
That's it. And so, what's the equation of the tangent?
So not the gradient.
The equation of the tangent in general would be the final equation of the line.
So it's y equals 11x plus 11x minus 28.
Yeah, hold on. So in general, find there's a few different ways of doing it, but find the gradient using the gradient function, and then find C. There's a few different ways of doing that as well. Let's see. I'm just considering. See how we do. There's a different way of going about it. I'm just not sure which way would be better. Okay, let's try 4a.
Okay. So it becomes 2x minus 5.
Mm-hmm.
Okay. Then do we substitute 5 into the equation?
Yeah.
So it'd be 10 minus 5, which is 5.
Yeah.
And then do we use y equals mx plus c?
We would, except we need a y first, and we don't have one. An idea how we get one?
Would you substitute x squared minus 5x plus 4?
You'd sub 5 into that, yeah.
Okay. For x, so it'd be 5 squared minus 5 times 5 plus 4, which gives you 4.
Yeah.
So that's the gradient. No, that's the y coordinate.
Yeah.
And then you use y equals mx plus c.
Yeah.
So it'd be 4 equals 5 times 4 plus c.
And yeah, go on.
So they'll give you 4 equals 20 plus c. And then you minus 20 on both sides.
Yeah.
Which is minus 16. So minus 16 equals c.
Okay.
So the answer is y equals 5x minus 16.
Yeah. And so I think what I'll mention to you now is, have you seen before y minus y1 equals mx minus x1?
I don't think so.
Ah, right. So I didn't bother with it. No, I'm happy with what we have here.
Okay.
Okay, they want now the equation of the normal when x is 3. Any idea what that's about, the equation of a normal?
No.
That means it has the perpendicular gradient. Any idea the difference between gradient and perpendicular gradient?
It's perpendicular gradient going in that, like, say if it was going horizontal, would it be going vertical?
Yes. So this is the tangent, and the normal is at 90 degrees, so it's directly head on. the gradient, if the gradient of the tangent is m, then the gradient of the normal is minus 1 over m. So it's the negative reciprocal. Where's this gone? The negative reciprocal. So the gradient for this one is 5. Any idea what the perpendicular gradient is?
Would it be 1 over 5?
Minus 1 over 5.
Okay.
It's when you multiply the two together, you get minus 1.
Yeah.
Okay, so now let's find the equation of the normal.
So do we sub it into the equation we have? 2x minus 5.
Sub what into 2x minus 5?
Minus 1 over 5.
No, that is minus 1 over 5.
Okay.
You could sub 3 into it, and you should get minus 1 over 5.
Okay. Oh, do we sub into y equals mx plus c?
No.
Oh, but do we? No, because we want y, don't we?
Yeah.
So we need to sub into x squared minus 5x plus 4.
Yeah.
So it'll be minus a fifth squared.
No.
Minus.
No. It's not m squared, it's x squared. M is minus 1 over 5. For part B, what is x?
Oh. So it'll be 3.
Yeah.
3 squared minus 5 times 3 plus 4. Is it minus 2?
Looks good.
And then can we use y equals mx plus c?
Yeah.
So it'd be minus 2 equals minus a fifth times minus 2 plus c. Which gives you minus 2 equals 2 fifths plus c.
Mm-hmm.
And then you minus 2 fifths on both sides.
Yeah.
Which is minus 2.4 or minus 12 over 5.
And so equation of the normal?
Is y equals minus a fifth x minus 12 over 5.
12 over...
And then you times everything by 5.
They didn't tell you to do that, but you could if you wanted, if you didn't want fractions.
Yeah.
Ba-ba-da-bum. Let me see. X. Doesn't like our answer. Did you put this into your calculator, right? Yeah, looks good to me. No, hang on. 5 squared. I think I put the wrong answer in the wrong place. I need to get the right answer. Sorry about that.
Right.
I just want to see something here. I think it'll be fine for that. It's a Q. Yeah. I think I'll do, even though it's very difficult, let's try question 7.
Okay. So can you turn y equals into x to the power of a half plus 1 to the power of minus a half?
X to the minus half.
Okay.
Like, 1x to the minus half. Something like that.
Okay. I got a half x minus a half to the power of minus a half plus a half x to the power of minus 3 over 2.
Yeah, and that should be minus a half x.
Okay.
Because it was minus a half.
Yeah.
Okay, what's next?
Now do we sub in 4 into that?
Well done.
I got 3 over 16.
3 over 16, okay.
Yeah. Then do you do the same for 2.5?
That is y. The gradient function only has x's in it.
Okay. So do we sub 3 over 16 into y equals square root x plus 1 over square root x?
That is x. This is m. We're trying to find the equation of a line.
Oh, so it's y equals mx plus c.
Yep.
So would it be y equals 3 over 16x plus c? But we don't know what y is yet.
We sure do.
Oh, it's 2.5.
Yeah. Hold on though. So go on. So what do you think it's going to be?
2.5 equals 3 over 16 times 2.5 plus c.
X isn't 2.5. Y is 2.5. What's x?
Oh, x is 2 over 16.
M is 3 over 16.
Oh no, that's m. Oh, it's 4.
So go on, say it again.
2.5 equals 3 over 16 times 4 plus c.
Good. However, that's for the tangent. We want the normal. What's different about the normal?
The reciprocal.
Yeah.
So do we minus 16 over 3?
Well done. So M1 is 3 over 16. M2 is minus 16 over 3.
So it'd be 2.5 equals minus 16 over 3 times 4 plus c.
Very good.
Yeah. So that gives us minus 113 over 6 equals x. No, c.
Okay. (143/6). Okay. And so equation of the normal
is y equals minus 16 over 3 x minus 130, not 13, 143 over 6.
Very good. And I didn't make that easy for you. You did that one yourself.
Yeah.
Yes. So your initial thoughts were basically the equation of the tangent, which is when you would use 4, 2.5, and 3/16. For the equation of the normal, you use x, y, and the negative reciprocal. Okay. Now we have to do this hard stuff, and it's a bit different. We have to, you see this point where the tangent crosses the normal?
Yeah.
We'll have to find where the coordinates at that point now in a second, I think. Or something, who knows what. Find the equation of the normal at this point. So we've done that already. That's fine.
Yeah.
This was the one. The tangent found in part A intersects the normal in part B at the point P. So find where these two intersect. But let me put that there, because we already have most of the information we needed. So the tangent in part A was y equals 5x minus 16. The tangent in part B was this.
Yeah.
We have to find out where they intersect with each other.
Yeah.
Any idea how you do that?
Okay.
Where do these two lines cross over?
Wait, so y equals 5x minus 16, what is that?
So that was the answer to part A. This was the answer to part B. So this was the tangent,
Okay.
this was the normal.
Okay. Do we need to make them equal to something, like what y is?
We need to find out. So this line is going to look like that. This line is going to look like that.
We want to find the intersection.
And we need to find the coordinates at that point.
Yeah.
Any idea how you go about that?
Would you use a simultaneous equation?
That's the best thing you could have said.
Yeah.
How would you do that?
You'd need to work out... Would you need to work out what x and y is first?
That is the answer to the simultaneous equation.
Okay. But you can't just put y equals 5x minus 16 as a simultaneous equation because you don't know what it's equal to.
You could put y and x on the same side and the number on the other side.
Oh yeah, you could. So could you just make it 16 equals 5x minus y?
5x minus y is 16.
And the other one can be 12 over 5. Well, what minus the fifth x minus y equals 12 over 5.
Yep.
Okay. Minus 1.
Oops.
I got x is 34 over 13, which is, okay, that's a lot of numbers. And y is minus 38 over 13.
So, looks very wrong, but we'll see if it is. Oh, was this the one with the wrong answer? Yeah, this was the one where I didn't have the right answer. I need to fix that. But,
Okay.
great. That's good. Let me just see some. I just want to use their answers for part A and B. So, if I was to use their answers, it would be 5, it would be minus 1 and minus 21. Then for this one, it would be minus 1, minus 1, and minus 1. So I'm getting minus 10 over 3 and 13 over 3. Let me see, minus 1, minus 1, minus 1. So they're just very confused. They're just very, very confused. So I don't even know what the question is for part C. I'm just assuming it's similar, but yeah, it's just the wrong answer.
Yeah.
Okay. Best thing in the world you could have said is simultaneous equations. That just gave it the simplest, easiest way. Okay, let's try this one.
Okay. So it'd be 3x to the power of 2 minus 4.
Mm-hmm.
And then can you substitute minus 1 in?
Mm-hmm.
Which gives you minus 1.
Yeah. Let's see. Go on.
Okay. And is minus 1 m?
Yep.
So then do you substitute into y equals mx plus c?
Yep.
Should be y equals minus 1x plus c.
Yeah, so far so good.
And then you need to get y.
Yes. How would you do that?
Do you have to put number into the original equation?
Yeah.
Or do you put minus 1 into the original equation?
Yeah. And you would get 3, I believe.
Okay. Minus 3. Yeah, you get 3.
Yes.
So 3 equals minus x plus c.
And I believe when you solve for C, C is 2. So that's your answer for part A. I just needed that for part B. Okay, how do we do part B?
Okay. So do we need to solve 3 equals minus x plus 2? Do we need to solve that?
No.
Okay.
Maybe I shouldn't have skipped, but I just solved that bit for you for C.
Oh, right, okay.
And I got 2. 3
Yeah.
minus 1, 2.
Do we already know what x is? X is minus 1.
At the point where x is -1. Okay, what do you know about the point? So a different point now, where this tangent meets the x-axis.
Yeah.
What do you know about every point on the x-axis?
y0.
Yes. And so use that to find the coordinates of A.
Okay. So could use y equals mx plus c again.
Yeah.
So it'd be 0 equals. But we don't know what x is. X minus 1.
We're trying to find x.
So it'd be minus x plus 2.
Mm-hmm.
And then we can minus 2 on both sides.
Mm-hmm.
So minus 2 equals minus x. And then we can times by minus 1 on both sides.
Mm-hmm.
Which gives you minus 2 equals x.
-2 times -1?
Oh. Oh yeah, so it'd give you 2.
That's it. And so coordinates of A?
Coordinate of A is brackets 2 comma 0.
Yeah. So just that's what they asked for.
Yeah.
And any idea how you go about C?
Okay. So would you substitute 2 into would you substitute 2 into 3x squared minus 4?
No, it doesn't lie on the g dash of x, it lies on the g of x.
Okay. So would you use Would you use y equals minus x plus 2?
No. We want to show that it lies on the g of x, and y equals the g of x.
So how would you work it out then?
You don't sub it into the g dash of x, you sub it into the g of x.
So is it... Oh, so it's x to the power of 3 minus 4x.
Yes. And so to show that...
Yeah.
Go on.
So it'd be... Yeah, 8. So
Yes. So that's where you sub into.
0.
Yeah. And that's what you should get. Basically, when x is 2, y is 0. When x is 2,
Yeah.
y is 0. And so that's how you show that. You can see how it's like a 1 mark question. Yeah. Let's see. Y equals minus x plus 2. The point was 2, 0. And x is 2. The g of x is 0. So, oh yes, it's a show that question. It's a show that. Therefore, copy paste. A lies on the curve. There we go. Yeah. They wrote so. So A is on the curve. Y equals g of x. Great. Let me see about this one. So we only needed to do part A, so I could do the other two. To find where the straight line meets the x-axis, you let y be 0, solve for x, because on the x-axis y is 0. And then to show that a point is on a curve, sub in x, get the y, and show that it's the same thing.
Yeah.
So let's see these. So, yeah. The normal to the curve at P intersects the curve. Yeah. Let me think about this. All right, let's try the top one.
So does y equals 2x squared become 4x? Y equals 4x.
Dy dx equals 4x.
Okay. And then do we substitute a half into it for x?
Yep.
Which gives you 2.
Yep.
Then we substitute 2 into 2x squared.
No. This is m, that is x. That's a formula for x.
We substitute a half into it.
Yep.
So it'd be 2, so it'd be 2 times a half squared.
Mm-hmm.
Which is a half. So is that y?
Mm-hmm.
So a half equals m, which is 2.
That is m1. That would be the equation of the
We want the
tangent.
reciprocal, so it's minus a half.
Yep.
Times a half. Plus c.
Are they serious? Okay. All the halves.
Okay. Which is minus a quarter. So a half equals minus a quarter plus c.
Mm-hmm.
And you can add a quarter to both sides.
Yep.
Which is 3/4, which equals c. And then they want the coordinates of q.
We're not there yet. So finish this bit off.
So 3/4 equals c.
Yeah. And m2 is minus a half.
Oh, right. So it'd be y equals minus a half x plus 3/4.
Yeah. And let's see. The normal to the curve intersects it. Yeah. So you've got some quadratic curve. You have some point line going through it. This point is P that we had x is a half and all that. We want this other point Q. How would we get that?
Wait, so we have p.
They gave us P. It had an x coordinate of a half, y coordinate of a half as well. So we have a straight line, we have a curve, we have to find where they cross over. How do you do that?
Wouldn't that be a quadratic equation?
Okay, what would be the equation?
Could it be 2x squared?
It has to be equal to something for it to be an equation.
Equals minus a half x plus a quarter.
You're on fire today. That's it.
And then do we minus a half x on both sides?
Plus a half.
Oh, no, do you minus 2x plus squared? Sorry. 2x squared, sorry.
Yeah, that would work.
Okay. So it'd be minus 2x squared, well, it's all equal to 0, minus a half x plus 3/4.
Yep.
Then we can work that out. So I got for x1 is a half.
Yeah.
And x2 is minus 3 over 4.
Minus what was it, sorry?
Minus 3 over 4.
Yeah. And so they gave us the half one. That was p. So our one is x equals minus 3 over 4. Is that 6 marks?
No. We want the coordinates, we don't have y for it.
Uh-huh.
So do we need x1? Or, like, because we have got two x's. Oh wait, no, the first one was for the p, wasn't it?
Yeah.
Alright, okay.
So it kind of confirmed.
So y equals mx plus c again.
Yeah.
Would we use what we used before, actually? Would you substitute minus 3 over 4 into 2x squared?
That'll work, yeah.
Okay. 3, 2, 6. Which gives you 9 over 8.
And so what's the coordinates of the points of intersection?
So would you do it as y equals mx plus c?
No, coordinate.
Oh, is that y? Yeah, it's y. So it'd be, for q, it'd be brackets minus 3 over 4, comma, 9 over 8. Close brackets.
9 over 8. Let's just see something. I'm looking for part C, was it? Am I looking at the right question? I need to fix these answers. Let me just see some. So find the coordinates of Q. I don't have the end of the answer, but yeah, a half, a half, a half. Yeah. Great. So big picture, let's see, is find the equation of the normal and make that equal to the equation of the curve and see where they cross over. Yep.
Yeah.
Any questions about that one?
No.
I'm very, very, very happy with this stuff, I tell you. Let me see this. Makes a triangle, don't they always? Don't they always? Let me see this one. We did part B. Oh, you're gonna make me do that. No. Okay, how about this one? What do you give yourself?
Probably a tick.
See, that's great. So the coordinate geometry that you did before, this brings together two different things, differentiation and coordinate geometry.
Yeah.
Yay, okay, we're out with that difficult stuff. Now back into this. This is easier stuff, I think. Let's see. So a function is increasing. If the gradient's greater than 0, the function's decreasing if the gradient is less than 0.
Okay.
Hopefully that's all right. Hopefully I'm not oversimplifying that. Okay, how about this one? Aha, if the gradient function is greater than 0 for all values. Okay, yeah. So how do we go about this one?
Could you solve it as a cubic?
No. Let's see. To show that it's increasing, you have to show, so increasing, f dash of x is greater than or equal to 0. So we have to show that f dash of x is greater than or equal to 0.
So would it be 3x to the power of 2 plus 24 plus 0?
3x squared plus 24 plus 0, which is 24, yeah. Okay, how do we show that this is greater than or equal to 0? Okay, so that's greater than or equal to 0.
Yeah. How do you know if it's like less than 0? or greater than or equal than?
Less than. Hang on. Well, less than would be if it was decreasing, but we have to show that this is increasing. This isn't what I was expecting. I have to say 3x squared plus 24. Okay. If I divide everything by 3, I get x squared plus 8.
Well, and then you could minus 8 on both sides, then square root.
But you can't square root a negative. I thought it would be completing the square. Plus 3. Is this wait, yeah, okay. It's my fault. What do you know about x squared? What is x squared always greater than or equal to?
1.
Even smaller than that?
0.
Yes. It can never be negative, but the smallest it can be is 0. 0 squared is 0. Minus 1 squared is back up to plus 1. And something like a half squared would be a quarter.
Yeah.
X squared is always greater than or equal to 0. What about 3 times that? 3 times x squared?
Still 0.
Still 0. What about if you added 24 to both sides? 3x
24.
squared. 24 is greater than or equal to 0. Sorry, was greater than or equal to 24.
Yeah.
Which is definitely greater than 0.
Yeah.
And so the 3x squared plus 24 is greater than 0 for all real values of x. Therefore, it's an increasing function.
So, say if it was minus 24, would that be decreasing?
If it was minus 24, I think it would be ambiguous. It would have to be the whole thing would be negative.
Oh, okay.
It would have to be something like minus x squared, because minus x squared is always less than.
Yeah.
Yeah, so I'll leave that alone. Okay, but yeah, so I kind of oversimplified that first page. Yeah, so basically, if it is increasing, then the gradient function is always greater than or equal to 0 for all real values of x. Decreasing, other way around. Let me just see something. Okay, let's try this.
Okay. So would you multiply x by everything in the minus x by everything in the bracket first?
Uh-huh.
Okay. So it'd be 4 minus 2x cubed.
Uh-huh.
Minus 3x.
Yep.
And then would it be easy if you put 4 at the end of the...
Yeah, if you like.
Okay. So would it be equal to 0?
No. That's the f of x.
So that becomes minus 6x to the power of 2 minus 3 plus 0. Well, you don't need the plus 0. And we know this is negative, decreasing.
Yep.
Because all values are negative.
Mm-hmm.
Therefore, the function f of x 4 minus x 2x squared plus 3.
You have to show it. So.
Do you need to write out what you did before?
Yeah.
Oh, okay. So x squared is greater than, no, minus x squared is equal to or less than. Is that right?
Yeah.
To 0. So minus 6x squared is still greater than or equal to. No, it's lesser than or equal to 0.
Mm-hmm.
But minus 6x squared minus 3 is less than 0.
Mm-hmm.
So therefore, the function f of x is decreasing for all values,
Real values.
real values. Is that what that like thing shows? That symbol?
Yeah.
ER.
X is an element of the real numbers. It's because in further maths you have imaginary numbers.
Yeah.
Very good. Decreasing function, and maybe I'll just mention, I think these two can be incorporated into one thing. You can skip this bit. That's just kind of my own common sense thing. You don't have to if you don't want to. But the smallest x squared can be a 0, and that's the type of thing. So then the biggest x squared, sorry, the biggest minus x squared can be as 0. But they'll allow you to just go straight to this bit. Like if a negative x squared would be less than, a positive x squared would be greater than.
Yeah.
Whichever you feel comfortable with. I always have to do it fully. Okay, okay, let me now go back. Okay, how about this?
Okay. So would that become 3x squared plus 6x minus 9?
Mm-hmm.
How do you know if it's but it's not decreasing?
They tell us it's decreasing, so they say find the values of x for when it is decreasing. Any idea how you do that?
Would you do the derivative again?
No. If it's decreasing, what do you know about the derivative?
It's negative.
Yep. It's less than or equal to 0.
Yeah.
And then calculator.
Okay.
And it's not equal to, it's less than, so it's B.
Okay. Three. Oh, it has to be less than or equal to. Oops.
Yeah. Why? What did you do?
I did less than.
You'll get the same as what I got here, except that yours won't have equal to.
Okay, minus 9. I got minus 3 is less than or equal to x, and x is less than or equal to 1.
Yep. So it's x is between minus 1 and minus 3 and 1.
Yeah.
There we go. I'd love to. Okay. How about this one? Yeah, that's a brilliant question.
So it'd be 2x plus p.
Yep.
So would you substitute minus 1 into that?
Let me see. Well, it's increasing. So what do you know about this?
It's positive.
Yeah. And how do you write that as an inequality?
2x plus p is greater than or equal to 0.
Okay. And so it's in this interval, find one possible value for p. Any idea how you do that?
No.
You would sub either of these in for x and solve for p. we're saying like when x is -1, it should be bigger than or equal to 0. When x is 1, you could sub in 0, you could sub in a half.
So you can't sub in -1.
You could sub in -1, but you couldn't sub in -2.
So would it be -2 plus p?
Yep. Is greater than or equal to 0.
Yeah.
And so you had to pick the negative one. All right. What is p then?
2.
Yeah, p is greater than or equal to 2. Is that right? Or p is just p would just be 2, I think.
Yeah.
Yeah. Okay. That stuff. What do you give yourself?
Tick.
We got it. Great. And we got 2 sections. I'm happy. Yes. And so continue this next time.
Yes.
Any questions from you in general?
No.
Well done, Adam. You did great. And have a good weekend.
You too.
Cheers. Goodbye.
Bye.
Bye.